Okay, now here's our situation. We have a certain number of sane people and a certain number of demented people. 20% of the sane become demented, 10% of the demented become sane. We hypothesize that after an infinite length of time, the number of sane and the number of demented people will be unchanging. And we can prove that that will actually be the case. We're going to just make that assumption right now. It's kind of just an assumption at this point. Now, if both of these are unchanging, what can we say about this picture? Well, one student in class said the flows are equal. What's that mean? That means the flow of sane over to demented and demented over to sane should be equal. Now, the flow of sane to demented is 0.20 s. The flow of demented to sane is 0.10 d. If those are equal, then the number you're losing from the sane is the number you're gaining from the demented. And the number you're losing from demented is the number that you're gaining from the sane. And that will give us a stable population. And of course that occurs when 0.20 s equals 0.10 d. 0.20 s equals 0.10 d is the condition for a stable population. So now what do we know about the population? We know, first of all, that the number of sane plus the number of demented isn't going to change according to this model. Total number of people is always going to be 1,000. And also that 0.2 s equals 0.10 d. That's what we know. When we're trying to solve a problem, it's very, very often the best thing we can do is write down what we know in some kind of symbolic form, and that's what we've done here. This consists now of two simultaneous equations in S and D. Two simultaneous equations and two unknowns can be solved. So we solve these equations for S and D. From the second equation, we could solve for D, let's say, and it's very straightforward. We solve this equation for D, we get D equals 2S. So if D equals 2S, then we can put that into the first equation. We're going to get S plus 2S equals 1,000. Okay? From S plus 2S equals 1,000, we conclude that S is 33 1/3. So what's D going to be? Well, D is 2S. Double 33 1/3 is 666 2/3. So we see here that we can determine, assuming that the population approaches a stable configuration, we can determine the populations of that stable configuration. It's going to be 1/3 sane, 2/3 demented. We can symbolize this process if P sub SD stands for the probability of going from sane to demented, and PDS the probability of going from demented to sane, then we see that the condition for stable population is that PDS times the demented, this number, equals PSD times the number of sane, here. So this equation sets these two flows equal. Now, we know again that D plus S is 1,000. Let's assume that D plus S is 1,000. If it was a different number, it would be easy enough to modify it with a different number. We could put a symbol here for this number, but let's leave the 1,000 because we can relate to that. Okay, so D is PSD over PDS times S. How do we get that? Well, we solve this equation for D. All we're doing is following the same procedure that we did with the numbers. Remember, we had 0.10 D equals 0.20 S. We divided both sides by the 0.10, and we got D equals 2S, right? Here we're getting D equals PSD divided by PDS times S. If we substitute that expression for D into the equation that said D plus S equals 1,000, well, we get PSD over PDS times S plus S equals 1,000. And if we then factor out S, we get S times PDS PSD over PDS plus 1, just factoring S out of this side. And then we can divide by what we factored out here. Get 1,000 over this mess. And then we put this over common denominator, and we'll have PSD over PDS plus PDS over PDS, giving us PSD plus PDS over PDS. We invert that and multiply, and we get this. So this is a straightforward solution for S. And here's the expression that we get for the number of sane people. For the number of demented people, well, it's 1,000 minus the number of sane. If you take 1,000 and subtract this expression for the number of sane, this is what you get. And notice that this is just PSD over PSD plus PDS. This is PDS over PSD plus PDS. So that whatever your initial population is, the number of sane will be your PDS over this denominator. Your number of demented will be PSD over this denominator. Those will be the ultimate numbers of sane and demented after an infinite time.